Hello, this is Mark Anderson for Keller Community College, and we are going to look at a hyperbola with X Intercepts. Now, there are two different kinds of hyperbolas that we'll be looking at in this chapter. They both have in common, they both have the center at their origin, or basically they're centered around the origin. They don't actually intersect with the origin, but there's not going to be any shifting of these hyperbolas up, down, or left and right. So they have a very general equation. And if you just watch the video that I did on ellipses, you're going to see that the equation up to a certain point is exactly the same. So we have our x squared over a squared, our y squared over b squared is equal to 1, but the difference, instead of a plus, it's a minus. Now if we have this situation, we're going to have these curves will actually open to the left and open to the right. And as these cross the x-axis, they will have two intercepts at a, 0 and also at negative a, 0. Now we're going to create some asymptote lines, and those asymptote lines are going to be the equations y equals b over a, x, and also y equals negative b over a, x. And we're going to plot those asymptote lines to show you that these are what they will approach but never touch as they get closer and closer or further and further away from the origin. So what we're going to do is just kind of set up what we're going to graph, and I'm going to do problem number 3 first and then do problem number 4 on the graphs below this. And so I will unfortunately have to move the screen, so if you're taking notes at home, you may want to jot these down before I have to move the screen, because this first graph, problem number 3, is going to have x-intercepts at 8, 0 and also at negative 8, 0. Now the two asymptote lines are going to be y equals, and I'm going to use b over a, so the roots of 49 and 64 are 7/64, sorry, not 7/64, 7/8 x, and also y equals negative 7/8 x. So what I'm going to do is graph these intercepts, graph these asymptote lines, and I'd also like to find 2 more points on this, actually 4 more points on this these sets of hyperbolas, because I want to see where see where they land and see how they curve. So let me move down to the graph below here. All right, give myself just a little bit of space at the bottom for some algebra. Okay, so remembering up above, the intercepts were 8 and negative 8, so I'm going to put an x-intercept here at 8 and negative 8. There's negative 8 and there's 8. All right, and then what I'm going to do is I'm going to use the line y equals 7/8, and I'm going to draw the asymptote lines first, or after the dots here. So now a slope of 7/8 means it goes up about 7/8 for every 1. Another way to do it is to go up 7 and over 8 for the slope of 7/8. Now we start from the origin, since there was no y-intercept to that equation here, and I will just show you just a quick asymptote line like so. And to have a straight edge would be actually better here, but I'm freehanding this, and so you'll be provided rulers when you take the exam. From this dot, I'm going to go down 7 over 8, take us to this spot here. And again, this would be that other asymptote line, which is negative 7/8, which goes down about 7/8 each time. But again, I'm just going to make a dotted line like so, and make a dotted line like so. All right, so now I have this point at 8, 0 and negative 8, 0. And what I'm going to do is take my original equation, which was x squared over 64 minus y squared over 49 equal to 1. And what I'm going to do is I am going to plug 10 into my x. Now the reason why is I want to figure out where along the y-axis, because we know that these are going to kind of open up to the right and to the left, and I'm focusing on the one at the right. I'm going to plug a 10 in for my x, and as I plug in a 10 for my x, I get 100 over 64 minus y squared over 49, and that's equal to 1. Now I'm going to move that 164ths to the other side, So I'm going to have negative y squared over 49 is equal to 1 minus 100 divided by 64. If I type in the 1 minus 100 over 64, I get a decimal of negative 5,625 10,000ths. Now over on the other side, I have a negative y squared over 49. To get rid of this negative 49 on the left-hand side, I can multiply by negative 49 on both sides. Now if you want to take it a little slower, you could multiply both sides by 49 and then divide by negative 1. That would get me all the way down to the y squared on the left-hand side, and now the right-hand side is going to be, after I multiply this 4-digit decimal times negative 49, it gives me 27 and 5,625 10,000ths. Then I take the square root of both sides, and I get y is equal to plus or minus approximately 5, or exactly 5 1/4. So from 10, I can move up to 5 1/4, like so, and down to 5 1/4, like so. And there's my beautiful hyperbola. Now, I also have another matching hyperbola over here on the left-hand side, because if I had plugged in negative 10 in for my x squared, I would get positive 100. So if I started over here by plugging in negative 10, I would have got the same answer of plus or minus 5.25, because all the rest of the algebra would be the same. So I'm going to go down to negative 5.25 and up to 5.25 from my negative 10 and show, whoops, I'm missing the dot a little bit though. I'm going to show my symmetry of that hyperbola on the left and the right hand side. Alright, so for my final problem, I'm going to now take a look at this example. This example here is x squared over 16 minus y squared, y squared over 9 is equal to 1. Alright, so my asymptotes are going to be opening up, my hyperbolas are going to be opening up like this, and my asymptote lines are going to go, crisscross, and I am going to now find my intercepts. Now these have x intercepts, so this intersects at 4, 0, and also at negative 4, 0. And my equation is y equals b over a x, so that is going to be my 3/4 x, and then my other asymptote line is y equals negative 3/4 x. Alright, so now we are going to pan down to the bottom of this worksheet here. I strongly recommend that you may want to copy some of this down, because as I scroll down to the bottom, I can't scroll back up and see the writing that I've done. Alright, I'm getting my calculator on so I can compute what we're about to do next. Alright, so moving down, here we go with the intercepts of 4 and negative 4. Alright, so we got an intercept of 4. Whoops, forgot to turn my pencil back on again. Alright, so 4 and negative 4. And my equation is y equals 3/4. So that's up 3 over 4. So I'm going to have my asymptote line go this way. And I'm also going to go down 3 and over 4. So I'm going to have another asymptote line going this way. So there's one way. There's the other way. Alright, cool. So now what I'm going to do is I'm going to plug 10 into this equation to see how far my dot goes up or down from this location. So we're going to start off with the equation, and I'm going to start on the left-hand side here. X squared over 16 minus y squared over 9 is equal to 1. I'm going to plug 10 into my x, so now I get 100 over 16 minus y squared over 9 is equal to 1. Alright, so I'm going to subtract the 116ths from both sides. So now I have negative y squared over 9 is equal to 1 minus 116ths. Now I'm going to type that in really quickly here on my calculator off to the side of the screen. And I get an answer of negative 5 1/4. So that is negative 5.25. Alright, so my next step is I am going to now multiply both sides by 9. And I'm going to multiply by negative 9 because that's going to get rid of the negative and the 9. So I will just have y squared is equal to 47 1/4. If I take the square, and a quarter, not a half. There we go. Now if I take the square root of both sides, the square root of 47 1/4 is going to be plus or minus 6.87. So my answer for this is y is equal to plus or minus 6.87. So from 10 we're going to go up to about 6.87, and you'll see that because of I wasn't using quite the straight edge here, it does look like my dot touched my asymptote line, which it never should do. Your line should not touch the asymptote line. But again, that's kind of the danger of freehanding. Okay, so then we're going to go to this side here. So we're going to go to 6.87 as well over here, and negative 6.87 as well over here. And you can see that because of my freehanding, I got my angle off a little bit. So the asymptote line really would come down on the other side of it. But again, that's what rulers are for, and you will have one on the exam. And there is my hyperbola with X intercepts, and the center of this, or it's centered around the origin, so there's no shifting up or down from this position. Our final video is going to deal with hyperbolas that instead of having X intercepts, have Y intercepts. So click on that video if you want to see some of the graphs that open up and open down. Thank you very much for watching.